want to look at how we find this. So we know the variance tells us how far on average values are from the mean. So it's expected value of x minus expected value of 3. So this is my bad, expected value of x minus expected value of x. So this is by definition. Right? Because the definition of variance is it tells us how far it tells us how far on average values are from the mean. So it's the expected value of x minus expected value of x. We can derive and here just keep in mind we are saying variance of x is expected value of x minus expected value of x squared. This expected value of x squared is just a constant, right? This is a constant, right? Because when you take expectation of random variable, you get a constant, right? This is the expected value to meet the weighted average. This is just a constant. We can derive another form for the variance formula. So by definition, we know this is variance. We derive another form for this. So another form for the same variance formula, if we expand, it turns out to be variance of x is equal to expected value of x squared minus expected value of x whole squared. So this is expected value of x squared. This is the square of expected value of x. These two are not the same. Here we're taking expected value of x squared of a function of random variable x, which is the square function of that. This is expected value of x whole squared. Now, the derivation of this video. So now let's see. So we can calculate variance, and so we can calculate variance. So we can calculate variance in one of two ways. So we can calculate variance of x in one of two ways. Both are in one of two equivalent ways, and one of two equivalent because the second form is derived from the first form, right? So you can use either way. So variance of x, you can find it as expected value of x minus expected value of x squared. Right, so this is by definition of variance. Okay, we know variance tells us on how far on average values are from the mean. The second form is give variance of x, and this form is derived from the first form. The derivation is done at some other expected value of x minus expected value of x. So this is by computation. Right, so this is so there are two ways, two equivalent ways that you can find variance. You can either use its definition or you can use the other form derived from that. So let's go back to our previous example where we found expected value of x and expected value of x. Let's go back to our previous example. In the previous example, we had x to value 0, 1, 3. And then we had probability that x takes each of these values, and we had this given as a PMF of x. So now we want to find variance of x. Now, like we said, there are two equivalent ways to do this. For the method, how to do this? Let's first use this method where we can find variance of x using this form that we derived from the definition of variance. So method one that we're going to use, method one is going to be by formula that we derive from the definition of variance. So by formula, it says that variance of x is equal to expected value of x squared minus expected value of x whole squared. So we already found in our videos that expected value of x squared. So expected value of x is 1.75. Details of that. So the expected value of x squared is 4. So since we already have these values, so if we didn't have them, like we already calculated them, if we had it, then we would first find expected value of x and expected value of x squared, and then we would find variance of x equal to expected value of x squared minus expected value of x whole squared. So expected value of x we found is 4. Expected value of x whole square is 1.75 squared. So this turns out to be 0.9379. Let's look at how we could use method 2 also, which is by definition. So there are two equivalent ways. You can either use a definition or you can use the form derived from the definition. So second method is by definition, which says that variance of x is expected value of x minus expected value of x. Right? And here keep in mind that this expected value of x is just a constant, right? It's important to keep in mind when you take expectation of random variable, what you get is a constant, right? We just saw the expected value of x we already found is 1.75 for this particular example. So how will we use the definition? Let's look at that. Now recall. So when we use a definition, then we want to find expected value of this, right? Expected value. So we can think about this as we want to find expected value of this, right? So this is a function of the random variable. Here we're just taking x, subtracting a constant and squaring it, right? So this is a function of a random variable x. So recall expected value of gx, right? Expected value of any function random variable x is this, right? Gx probability x. In this case, the function of random variable x we're taking is, in this case, gx is just x minus expected value of x, right? This is what gx is. In this case, the function of the random variable whose expected value we want is just this, right? This is the function that we're looking at. So, using the fact of how we find expected value function random variable, so we can write this as summation. So instead of gx, we'll just put this function in x minus expected value of x whole square into bx, right? Because here gx is just simply, so here gx is just simply this, right? So expected value of x minus expected value of x whole square, this is our gx, right? Gx, right? So what we're doing is, we know, okay, how do we find expected value of any function random variable? We know we find it in this way. And here that function is just x minus expected value of x whole square, right? So this is essentially what we want to find. So this is our, right? This is what we want to find. Summation x minus expected value of x whole square x of x. And here it's very important to keep in mind that expected value of x is a constant. Right? Because when you take the expectation of a random variable, you get a constant. So essentially, we want to find variance of x is expected value of x minus expected value of x whole square. So we want to find the expected value of a function of the random variable x, where this function of the random variable x, gx is just x minus expected value of x whole square in this case. So let's do it. We'll adopt it as the approach. So here, method 1, where we're using the formula, we need to first find expected value of x and expected value of x squared. Here we just need expected value of x, obviously, to find it, because that is definitely part of it. So this is a constant in this case, 0 point. In this case, expected value of x is 1.75, already found it. So when you want to find this, so we know x takes value 0, 1, 2, and 3. So we know probability x is given to us as 1 by 8, 2 by 8, 3 by 8, 2. And then we have x minus expected value of x. Remember that what we're interested in is that we want to take, so we basically multiply g of x with px of x. For this, we want to find what x minus expected value of x whole square is for each value of x. And for each value of x, we multiply it with its corresponding probability, and then we add it, right? This is what we want. We want to see what x minus expected value of x whole square is. Ix minus 1.75 square is. Then we multiply for each value of x, we find what this function is. X minus, so for each value of x, we find the value of this function x minus expected value of x whole square, multiply it with its corresponding probability and add it up. We'll first find out x minus expected value of x. So it's 0 minus 1.75 is minus 1.75. So this is 1 minus 1.75 is minus 0, sorry. 1 minus 1.75, right? So this is minus 0.75. And this is 2 minus 1.75 is equal to 0. And this is 3 minus 1.75 is 1.25, right? So now we'll see what x minus expected value of x whole square is, right? Because see, the goal is to find the expected value of this function of random variable x. We need to evaluate x, you want to evaluate this function g of x. For each value of x, then you multiply its corresponding probability and then you add them up. This is what is right. For each value of x, find what x minus expected value of x whole square is, multiply with its corresponding probability and add. So if I now take the square of this minus 1.75 square, this just turns out to be 3.0625. And this would be minus 0.75 square. This would just turn out to be 0.5625. And then I do 0.5 square. This would just turn out to be 0.0625. And then finally we do 1.25 squared. This just turns out to be 1.5625. Sorry. Right. So now we have this, right? Let me just right. So let's just do this. Let's just erase this constant. We want this place, so let's just fix this. So now you know what x minus expected value of x squared is. We evaluated this function value for each value of x. Now we just need to multiply each with their respective probabilities in the NAR. So we're basically evaluating this for each value of x, and then we add them up. That's what the solution is, right? So it's x minus expected value of x squared, right? So now I just multiply, right? So I know for this value of x, this is this. So it's 1/8 into 3.0625. This turns out to be 0.3 into it. Right, and this is just 2/8 into 0.5625. This just turns out to be 0.1406. And then this is 3/8. Sorry. It's into this value, which is 0.0625. It just turns out to be 0.0234. And then for the last value, you do the same. So this is just 2/8 into 1.5625, which is just 0.3906. And then you just sum these up to get variance of x. So summation pxx, x minus expected value of x whole square is just the sum of all of these, right? So essentially what you're doing is now you just have to sum up all of these, right? And when you sum up all of these, you get the exact same answer, 0.9374. Just the decimal place is a little off. That was 0.9375. This is 974 because we just rounded off this. So essentially, using method by definition, we said, the variance of x is expected value of x minus expected value of x squared. This is by definition. Oh, sorry. So this is by definition. And then using the fact that how to find expected value of any function random variable x, where this is just simply g of x in this case. So we know this is going to be summation pxx into g of x. So this is just going to be x minus expected value of x. This is just simply us then applying how do we find expected value of any function random variable with this function is this, right? And this will just turn out to be 0.9374. Right, so in this way, using method 2, you can find expected value of this, right? So what we're doing is once here, when we're applying the definition, then we're just saying we need to find the expected value of this function, where g of x is just this entire thing, x minus expected value of x. So for each value of x, you just evaluate what x minus expected value of x squared is, which we've done by here, right? For each value of x, like 0, 1, 2, 3. So for x is equal to 0, the value, this function value is for 1, and then this for 2, and then this for 2. And then you multiply each with its corresponding probability. So you essentially find what this is. And then the summation means you just sum them.